Okay, so I want to jump back to the last type of example that we saw. We looked at f of g of x here, right? And then this is what we arrived at as an answer. So if we kind of consider this, I'm going to just write it off to the side so I've got room for it. So f of g of x, we've got 9 minus x over x minus 1. So as I said before, this is a function in and of itself, right? So by virtue of being a function, again, it passes the vertical line test. It has function values, and it has a domain. So on its own, we're very interested to start with what's the domain of just this function. Well, as a function, because it's a fraction, it's called a rational function. We'll get into more detail with them later. But the denominator cannot be 0, right? Which means x cannot be equal to 1. So the domain so far, I'll put so far, is from negative infinity to 1, union 1 to infinity, everything but that number included, right? Just that number removed from it. The other piece of the domain that we have to consider, though, because this is a composite function, because we plugged one function into another function, the other thing we have to consider is what's the domain of my inner function? Okay, so in this case, g of x was on the inside, right? So g of x, if it has additional restrictions, we have to take those additional restrictions out of the domain that we just found, okay? The reason is because we're plugging one function into another, right? I have to make sure whatever went into that first function, so technically things get plugged into g first and then f second. Whatever gets plugged into g, we have to be allowed to plug into g. So for example, do we see here that x cannot be equal to 1 as well? Right, for the same reasoning, really. But if I tried to plug in x is equal to 1, I would be plugging in g of 1 would be 4 over 0, which is undefined. How do I plug in undefined into f? Right, it doesn't really make sense. So I have to make sure the domain of the inner function is taken care of, as well as the domain of the resulting function. In this case, they agree with each other. So the final domain is just negative infinity to 1 and 1 to infinity. And as we move forward, we'll see some other examples where they're not necessarily going to agree with each other. If g had other values, say you had to take 10 out, right? If those numbers were different, we would have just also removed them from the answer we already had, okay? So it's just continuing to remove potentially difficult points.